Dear students, today we will see LPP using simplex method. To solve simplex method, there are two types of problems. The LPP for using simplex method for maximization problem, and second one is the LPP using simplex method using minimization problem. So we have already discussed the problem with maximization problem. So today we will see the minimization problem. So here example is solve the following LPP using simplex method. Mean z is equal to x2 minus 3x3 plus 2x5 subject to 3x2 minus x3 plus 2x5 less than equal to 7 minus 2x2 plus 4x3 less than equal to 12 minus 4x2 plus 3x3 plus 8x5 less than equal to 10 and x2, x3, x5 greater than equal to 0. So before solving the example, we should know the basic terminologies used in LPP programming. Or LPP. LPP is nothing but linear programming problems. So here the main function, main z function is called as objective function. We have to identify the value of x2, x3 and x5 so that the total value of z will be minimum. So if you put any value from x1, x2, x3, x5, we satisfy these constraints. These three expressions are called as constraints or conditions. This is my first condition, second condition, third condition. So to any value, we satisfies these constraints are called as feasible solutions. So if you put value of x2 is equal to 1, x3 is equal to 1, and x5 is equal to 1, and if you put those values and if you test all these three constraints, then we can say the 1, 1, 1 is a feasible solution. If you put value of x2, x3, x5 as a 2, 2, 2, and if you check the conditions, if all conditions are true, then we can say these are so 2, 2, 2 is also one of the feasible solution. So any solution which satisfies the given constraints, those solutions are called as feasible solutions. And out of those set of feasible solution, which gives minimum value of the objective function, out of those feasible solutions, which set of solution gives minimum value of objective function, that values are called as optimum values. So we'll see how to solve LPP using simplex method for minimization problem. To solve the problems, we have to identify the type of problem. In the given case, in this simplex problem, the problem objective function is for minimization. Then here x2, x3, x5, these variables are called as basic variable. x2, x3, x5, these variables are called as basic variables. Basic variables are the variables which are in objective functions. That variables are called as basic variables. And the value of minus 3, 2, here value is not given, but by default it is having value 1. So this 1, minus 3, 2, these are called as coefficients of this basic variable. These are called as coefficients of basic variables. In these constraints, we see that the equation is not equal. Means the left hand side of the equation is having some less value than the right hand side value. So this is we can identify with the help of the symbol less than equal to. So this less than equal to symbols indicates that in the constraint equations, the LHS side is having some value less than or equal to the right hand side values. Okay, so to make these inequalities into equalities, if the constraint contains less than equal to sign, then you have to add some slack variable, surplus variable. Surplus variable is a variable which is used to make inequalities and equalities if the constraint contains less than equal to sign. If your equation contains less than equal to sign, and to make the equation into balanced form, you have to add a slack variable in left hand side so that the equation may become balanced. Getting? Slack variable we have to add in this expression. So now we'll see how to solve. So before solving LPP problems, we have to check whether the given problem is for minimization or maximization. If the problem is for minimization, then you have to convert that into maximization. So given objective function is for minimization, because it is given that mean z is nothing but this is a problem for minimization. So we need to convert in maximization. To convert minimization problem into maximization problem, what is the formula? Max z star is equal to minus of mean z. Minus of mean z means we have to change the signs of all, we can say, objective functions, basic variables and constants. So in this case, I am converting this mean function into max function. So max z is equal to x2 is converted into minus x2, minus 3x3 is converted into plus x3, plus 3x3, plus 2x5 is converted into minus 2x5. So what you have to do to convert minimization function into maximization functions, you have to reassign the all variables or all constants value, or we can say all coefficients value. To convert minimization problem into maximization, you have to change the signs of coefficients of basic variables. So here we get minus x2 plus 3x3 minus 2x5. We have converted this min function into max function. Now we have to convert these inequalities into equalities. So here constant function has less than equal to sign. As we know that the rule is that if the constant function is having less than equal to sign, to make that inequalities into equalities, we have to add slack variable. So to convert inequalities into inequalities of constraints into equalities, we have to add three slack variables. Means what? There are three conditions. There are three constraints. That's why we need to add three different slack variables. If the number of equations are 2, then we have to add 2 variables. If number of equations are 4, then you have to add 4 slack variables. Okay. In the coefficient, in the constraint with coefficient 1. So when you are adding the values, we have to add coefficient value 1, and also in objective function with coefficient 0. So we have to add slack variables in constraint as well as objective function. So when you are adding that constraint in adding that slack variable in constraints, you have to add coefficient of that constraint coefficient of that slack variable is equal to 1. And when you are adding that variable in objective functions, then you have to add coefficient of that slack variable equal to 0. Okay, the LPP in standard form will be, we'll see how to convert these equations. Max z star is equal to minus x2 plus 3x3 minus 2x5 is the converted expression from minimization to maximization. Now we have to add three slack variables. I am adding s1, s2 and s3. These three slack variables I am adding, and as the rule says that if the constraint is having less than equal to sign, then you have to add three slack variables. I have added three slack variable, and the coefficient of that variable we have to add 0 in objective function. In objective function, the coefficient of slack variable should be 0, subject to, what was the constraint? 3x2 minus x3 plus 2x5 plus s1. I have added first slack variable in first equation, second slack variable in second variable, third slack variable in third equation with the coefficient 1. If I am not writing coefficient 1, then by default it is having 1 coefficient here. So the converted equation will be 3x2 minus x3 plus 2x5 plus s1 is equal to 7. Now I have removed the inequalities by adding the slack variable in first equation, second equation and third equation. So after adding the values, we will get these three balanced constraint equations, we can say. Now, how to calculate initial basic feasible solution? Now we'll see how to calculate initial basic feasible solution. You have to prepare one initial simplex table for a given function. So what you have to consider first? You have to draw simply one blank table. Actually, you have to take this as a blank table. Then the second, you have to start from this column. This is called as basic variable. Basic variables from the objective function. What are the basic variables now? x2, x3, x5, s1, s2 and s3. These are called as basic variables. The variables which are in objective function are called as basic variables. So we have to take those variables, basic variable x2, x3, x5, s1, s2 and s3 here. Then second one is Cj. Cj is nothing but coefficients of basic variable. These basic variables we have taken from our objective function. Now Cj is nothing but coefficients of these basic variables. So by observing this maximum from objective function, we can identify that the coefficient of x2 is -1, coefficient of x3 is 3, coefficient of x5 is -2, coefficient of s1 is 0, coefficient of s2 is 0, coefficient of s3 is 0. So once you identified basic variables of objective function, coefficients of objective function, then you have to identify which different variables we have added in your constraint. So we have added three variables, s1, s2 and s3. So those s1, s2, s3 variables we have added in constraint as well as objective function. So we have to take the values from objective function. So s1, s2, s3, these are the slack variables we have added that you have to write here, s1, s2, s3. And what are the coefficient of s1, s2, s3? 0, 0, 0 are the coefficient of these variables. Now what you have to do, we have to check in which expression, in which constraint we have added coefficient s1. So this is my expression where I have added s1 as a slack variable. So we have to check, is there an x2 variable? Yes, that is also contains x2 variable. Then what is coefficient of x2? 3. So I have written over here 3. x3, yes, it is available. x3, what is coefficient of x3? -1. So -1 here. x5, yes, coefficient of x5 is 2. s1, yes, it is having. s1, what is coefficient of s1? 1. This expression doesn't contain s2 and s3. So for s2 we have taken value 0, s3 we have taken value 0, and solution, the value that is at RHS, you have to write as it is. Likewise, you have to check this s2 slack variable we have added in which expression, that we have added in this second expression or second constant. So same we have to test what is the coefficient of x2, x3. In this case, coefficient of x2 is -2, coefficient of x3 is +4, but in this case we don't have x5. So what we have to take? 0, you have to take coefficient for x5. Then this expression doesn't contain s1, so we have taken coefficient of s1 is equal to 0. s2 is here, so coefficient of s2 is 1. s3 is not, keep that slack variable s3 is not added in second variable, second expression, so value is 0 and solution is equal to 12, that is the RHS value. Likewise, we have to check what is the coefficient of s3, which this slack variable we have added in which expression. So we have added this in third expression. So we have to add coefficient value of x2, x3 and x5 in this expression, in this initial simplex table, and this expression doesn't contain s1, s2, so we have to add value of s1 equal to 0, value of s2 equal to 0, and value of s3 is equal to 1 because s3 is having in this expression and its coefficient of this s3 is 1, and solution is equal to 10. So once you have calculated all those things, what is basic variable, what are the coefficient of variables, which slack variables we have added, what are the coefficient of slack variables in your objective function, then you have to identify this slack variable is added in which constraints. Those values you have to just add in this initial table. Then next thing is that we have to calculate values zj value. So how to calculate zj value? We have to multiply the values with this coefficient of slack value coefficient. So here to calculate zj value in this particular column, what I am doing, we have to multiply 0 into 3 plus 0 into -2 plus 0 into -4. So in this case we are multiplying with 0, and rule knows that if you multiply any value by 0, we will get 0. So in this case we have just multiplied these values by 0 and plus this value into 0 plus this value into 0, you will get 0. Likewise, for this value of zj, we have to multiply these values with coefficient of basic variable, that is slack variable values, will get 0. So in this fashion, you have to calculate all the zj values. In this fashion, you have to calculate all zj values by multiplying column value with coefficient of basic variable values. The next one is Cj minus Zj. How to calculate Cj minus Zj? So value of Cj is here. Value of Zj we have calculated. So just we have to subtract Cj minus Zj. Minus 1 minus 0, that is minus 1. 3 minus 0, 3. Minus 2 minus 0, minus 2. 0 minus 0, 0. In this fashion, you have to calculate Cj minus Zj. So once you calculate Cj minus Zj, we can identify whether you obtained the optimum solution or not. How to check that? If you have to check all Cj minus Zj values, and if all Cj minus Zj values are less than equal to 0 or not, we have to check. If all values are less than or equal to 0, then we can say we have obtained the basic feasible solution. But in this case, it is less than equal to 0. But it is not less than equal to 0. So we can say the optimality is not reached. Here, all Cj minus Zj not less than or equal to 0. Hence, solution is not optimal. We have now how to convert that. Now what is next procedure? We have identified whether the optimality is reached or not. So we come to know that optimality is not reached. So what we have to check? From the Cj minus Zj column, we have to check column which is having maximum positive number or maximum positive value. So in this case, my biggest number is 3. So this column is treated as key column. The column which contains maximum Cj minus Zj value, that column is called as key column. Now what you have to do? You have to divide key column values with solution value. Means we have to divide 7 by minus 1, 12 by 4, 10 by 3 in this fashion. So in first case, what we are doing? 7 divided by minus 1. So as a mathematical rule, it says that we cannot divide any number by negative number. So it is not divisible or not defined, we can say, not calculated, because the denominator of this expression is minus sign. So you cannot divide number with minus sign. So it is not possible to calculate. So 12 divided by 4, that is 3. 10 divided by 3, 3.333. So when you calculate this ratio by dividing solution by key column means the column which is having maximum positive value is called as key column, we will get the ratio. Then from the ratio, we have to identify which is minimum value. See, in case of Cj minus Zj, we are taking into consideration maximum value, but in case of ratio, we are taking minimum value of the ratio. So here minimum value is 3. So this row is called as key row. The row which contains minimum value, that row is called as key row, and the column which contains maximum Cj minus Zj is called as key column. So the cell which is intersection of key row and key column is called as key cell. The intersection of key row and key column is called as key cell. So here key cell is this, key cell is having value 4. Now from this what you understood? From this it is understood that in this case the variable S2 is referred as living variable and variable x3 is called as entering variable. So in next step what you have to do, we have to remove this s2, and in the place of s2 we have to add the values of x3 and coefficient of x3. Getting? So how we identified key column or key row? In case of key column, say the value Cj, we have compared all Cj minus Zj values. The whose Cj minus Zj value is maximum, that column is called as key column. Then we have divided the values of key column to solution values, and from that we have calculated the ratio. from the ratio, which value of ratio is minimum, that row we have selected as a key row. An intersection of key column and key row is called as key cell. From the key cell value, we come to know that which is the living variable and which is the entering variable. Which is the living variable and which is the entering variable. Okay, now see here living variable is s2 and entering variable is x3 and the key element is 4. Getting? Now how to solve this? The rule is that we have to do such operations that the values of key cell should be 1. We have to make k cell value is equal to 1 and other values from that particular column, other values from this key column we have to make 0. So as we know that if you want to make value of this key column 1, then what you have to do? We have to divide whole, we can say, row by 4. If we divide 4 by 4, we get 1. So make this key cell value 1. What you have to do? You have to divide this whole row by 4. So we can write this is my first row, second row, third row. This is my first row, second row and third row. So what formula I am going to write here? The revised new matrix will be obtained using following formula. What is my formula? New R2. So I am going to calculate first. This is my second row. That's why new R2. R2 is nothing but row number 2. New R2 is equal to old R2 divided by 4. So if I want to make this cell value 1, why I am taking this value? Because this is my key cell. We have to start from key cell value and the key cell value should be 1. So if you make this, if you want to make this value 1, we have to divide this value by 4. That's why the same operations you have to do for all values from that particular row. So what you have to do? New R2 is equal to old R2 divided by 4. Now see, this is my R2. In case of R2, this was my living variable, so I have added here S2. Instead of S2, I have taken X3 and coefficient of X3 is 3. So here I have added my entering variable. I have removed my living variable. Now what is the case? If I divide, this is my old R2. This is my old R2. Just I will do. Okay, old R2. What is the rule? Old R2 is equal to new R2 is equal to old R2 divided by 4. So I have to write. I have to enter all the new values for this R2 row 2. So minus 2 divided by 4. Minus 2 divided by 4 is nothing but minus half. 2 if you divide minus 2 by 4, 2 into 1, 2 is to 1, 2 into 2 means minus 1 by 2 is the answer. So in second case, 4 by 4, 1, 0 by 4, 0, 0 by 4, 0, 1 by 4. Because old value is 1, we have to divide the old value by 4, we get 1 by 4. 0, 0 by 4, 0. Now 12 by 4, I have to divide 12 by 4, I will get 3. So now I have a new R2 with the value minus 1 by 2, 1, 0, 0, 1 by 4, 0 and 3. Then what is next rule, next formula? See. New R1 is equal to old R1 plus new R2. So this is my old row. These are my old row 1 and this is my now new R1. This is my new R1 and this is my old R2. So what I have to do? I have to make this value 0. So old value is minus 1, new value is 1. So what I have to do? Minus 1 plus 1 is equal to 0. This is the rule I know. If you do addition of minus 1 and plus 1, you will get 0. So this is a value, this cell is having value minus 1. This cell is having value -1, and now new key cell is having my value 1. So if I add this expression, if I add this row in old row, I will get this cell value 0. So what I am doing here, new R1 is equal to old R1 plus new R2. So here, what is the value of x2? 3. What is the value of here x3? -1 by 2. So 3 plus -1 by 2. 3 plus -1 by 2, we will get 5 by 2. Means you have to do multiplication. 3 to 2, 6, 6 minus 1, 1, 5. 5 by 2 is the answer. Likewise, -1 plus 1, 0. 2 minus 0, 2. 1 minus 0, 1. 0 plus 1 by 4, 1 by 4. 0 plus 0, 0. 7 plus 3, 10. Getting? So just we have to put the values of old R1 and new R2 in the expression. You will get new row 1 for the revised simplex table. Just you have to take into consideration these formulas. Because what is the key concept? When you identify key row and key column and key cell, the key cell value must be 1 and other corresponding cell value of that key column should be 0. So we have to make value of this cell 1 and the other cell value we have to make as 0. So when this value is 1, to make this value 0, what we have to do? We have to add this value. Now this is a 1 and this is a 3. So what we have to do? We have to multiply by all this second row by 3 and then you have to subtract. That's why what is the third formula? New R3 is equal to old R3 minus 3 times new R2. Because R2 value is now 1. If I want to make this column 0, this column is value is having 3, then 3 3 minus 3 times this row is nothing but old R3 minus 3 into new R2. So here what you have to do, just add all the values here. New R3 means if you want to calculate this value, new R3 is equal to old R3. What is old R3? That is -2. Sorry, -4. -4 is the old value of R3. -4 minus 3 into new R1. Value of new R1 is -1/2. 3 into new R2, sorry. Value of R2 is -1/2. So what is the formula? Here, -4 minus 3 into bracket -1 by 2. So if you solve this expression, you will get the value of x2 at this cell is -5 by 2. Likewise, 3 minus 1, 3 minus 3 into bracket 3 into 1. Because R2, the value of R2 is 1. So you have to multiply by 3 to this particular row and subtract this row from old row. So we will get 0. So here 8 minus 3 times 0. That is 8. 0 minus 3 into 0. 0. Here 0 minus 3 into what is the value of here x2? 1 by 4. So 3 into 1 by 4, 3 by 4, and that you have to subtract. That's why -3 by 4. So in this fashion, if you solve this expression, you will get all the converted values. Same we have to calculate now ZJ value. How to calculate ZJ? We have to multiply this key cell value with coefficient value. So 0 into 5 by 2 is 0. So 3 into -1 by 2, -3 by 2. 0 into 5 by 2, 0. So if you do addition of all those things, you will get -3 by 2 is the ZJ value. Same in this fashion, 0 into 0, 0 plus 1 into 3, 3 plus 0 into 0, 0. If you do addition of this, you will get 3. So you have to calculate ZJ value for all columns. Then Cj minus Zj. Value of Cj is given here you have to subtract value of Zj from the value of Cj. So Cj minus Zj will get minus 1 minus 3 by 2, minus 1 minus 3 by 2, minus it becomes plus 3 by 2. So minus 1 plus 3 by 2 is equal to 1 half. Likewise, you have to just put the values C of this Cj and Zj and do the calculation. You will get Cj minus Zj. Same as discussed earlier, we have to check whether the optimality is reached or not. How to check? If all Cj minus Zj values are less than or equal to 0, then and then only we can say the optimality is reached. So here, if you check all the values, you can come to know that the first value, this is 1 half, is not less than or equal to 0. So this column I have to select as my key column. And what you have to do? We have to divide these key column values to the solution values. So here 10 divided by 5 by 2. 10 divided by 5 by 2, if you do calculation, you will get 4. Then 3 divided by minus 1 by 2. As we know that you cannot divide any number with my negative value. So not defined. So which is the minimum value from this ratio values? Now only one value we found, that is 4. So we have to select this row as a key row because this row is having minimum ratio value. So the cell which is having intersection of row and column is called as key row. The same rule we have to apply. We have to make key row value is equal to 1 and other values we have to make as a 0. We have to make this key row, key cell value is equal to 1 and corresponding values of that particular column should be 0. So what you have to do to make this column as equal to 1? If you multiply this value by 2 by 5, if you multiply this value by 2 by 5, then we will get 1. 5 by 2 multiplied by 2 by 5, denominator and numerator, that will be cancelled one another against one another and it becomes 0. So how to solve this? Here all Cj minus Zj's is not less than or equal to 0, hence solution is not optimal. Here living variable, you have to take into consideration. This is the key row column. So this variable is called as living variable and this variable is called as entering variable. So in the revised matrix, we have to remove this S1 and 0. And instead of S1, we have to add X2 and instead of 0, we have to add coefficient of this X2, that is minus 1. So here S2 is called as living variable, S1 is called as living variable and X2 is called as entering variable. Okay, and the key column is 5 by 2. As the rule says that we have to make this value 1. What you have to do? See what changes we are doing. Just we are multiplying old value of R1. This is my row 1, this is row 2 and this is row 3. So we are just multiplying old value of R1 into 2 by 5. So we have to multiply 2 by 5 to all elements of this particular row up to this solution. So 5 by 2 into 2 by 5, we get 1. 0 into 2 by 5, 0. 2 into 2 by 5, 4 by 5. 1 into 2 by 5, 2 by 5. 1 by 4 into 2, 1 by 4 into 2 by 5. If you solve this example, we will get 1 by 10. 0 into 2 by 5, we get 0. 10 into 2 by 5, 10 into 2 is equal to 20. 20 by 5 is nothing but 4. Getting? So we identify this new R1. First, you have to identify new R1 with the formula new R1 is equal to old R1 into 2 by 5. Once you identify this value, then what is next? We have to make the corresponding value from the key column to 0. So here new value is 1, old value is 1 by 2. So if you want to make this value 0, so what you have to do? I have to add 1 by 2. I have to add 1 by 2 into new row value. The new row value is 1. 1 into 1 by 2 is nothing but 1 by 2. So minus 1 by 2 plus 1 by 2 is equal to 0. So what is the row formula? To obtain the new value for row 2, you have to add half into new R1 into old R2. You have to add 1 by 2 into new R1 plus old R2. Likewise, if you want to make the value of this column or this cell, we can say 0. So what you have to do? We have to add 5 by 2, because minus 5 by 2 and plus 5 by 2 is equal to 0. As we know that minus 5 by 2, if we add it into plus 5 by 2, the answer will be 0. So no new R3 can be obtained by multiplying new R1 by 5 by 2 and adding that value to old R3. If you solve these examples by putting the values of these x1, x2, x3 and R1, and by taking into consideration value of R1, R2 and R3, you will get this matrix. So when you solve this, then you have to calculate Zj. As we have already discussed, to calculate Zj, formula is you have to consider the value of that corresponding column and coefficient values. Just you have to multiply 1 into minus 1, that is minus 1, 0 into 3, 0, 0 into 0, 0. If you add all these values, you will get minus 1. Likewise, 0 into minus 1, 0, 1 into 3, 3, 1 plus 0, 0. So if you add 0 plus 3 plus 0, we will get 3. Likewise, you have to just multiply this into this plus this into this plus this into this. You will get the value of Zj. So you have to calculate value of Zj for all columns. Then what is next? You have to calculate Cj minus Zj. Cj is here, Zj we have calculated. Then you have to just do the subtraction of Cj minus Zj. You will get Cj minus Zj. Once you calculate all Cj minus Zj, you have to check whether all Cj minus Zj values are 0 or less than 0 or not. So in this case, we can identify the first column value is 0, second is 0, third column is less than 0, fourth is less than 0, fifth is less than 0, and sixth is also 0. Means we can say that the optimality is reached because all Cj minus Zj values are less than or equal to 0. So what is next? Here all Cj minus Zj's are less than or equal to 0. All Cj minus Zj values are less than or equal to 0. Hence, optimality is reached. So this is the end of your example. So therefore, what you have to take into consideration? What is value of x2? For x2, value is 4. For x3, value is 5. For s3, value is 19. So we have to take into consideration only the basic coefficient of basic variables from your objective function. Basic variables were x1, x2, x3 and x5. So what is x value of x2? x2 is equal to 4, x3 is equal to 5, but x5 is not available here. So we have to take x5 is equal to 0. So x2 is equal to 4, x3 is equal to 5, x5 is equal to 0, and max z star is equal to 11. We have calculated the value for maximization function, max z star. And to convert the maximization function to minimization function, just you have to change the sign of answer. So mean z is equal to minus 11. So from this we can say that the objective function z will be optimum when you put value of x2 equal to 4, value of x3 equal to 5 and value of x5 equal to 0. You will get minimum value for objective function z. So in this fashion you have to solve LPP using simplex method for minimization problem. So while solving minimization problem, what things you have to take into consideration? First of all, you have to check whether the problem is for minimization or maximization. If the problem is minimization, then you have to convert into maximization. Then you have to check the constraint and the signs in the constraints, whether the left hand side is less than right hand side, or left hand side is greater than right hand side, or left hand side and right hand side both are equal. Means there might be having less than equal to sign, greater than equal to sign, or equal to sign. So in the given expression, in this given example, all signs are having less than equal to signs. So if in your constraint you are having less than equal to sign, then you have to add slack variable in objective function as well as constraints. But what do care you have to take into consideration? When you are adding slack variable in constraint, you have to add coefficient 1, and when you are adding slack variable in objective function, we have to add coefficient as a 0, and then you have to solve the particular problem. So here we have completed LPP using Simplex method for minimization. If you have any doubts, you can call me. My mobile number is 98500 98225. My name is Dr. B.J. Mohite. Thank you. Thank you.